Hello. We have just restocked the Microcosmos microscope over at microcosmos.store, and we now have two models available. One that comes with achromatic objectives, and the other that comes with plan achromatic objectives. And if you've previously purchased a Microcosmos microscope and would like to upgrade your objectives from achromatic to plan, we have a 4-pack of plan objectives on sale, as well as two brand new 20x and 60x plan objectives. You can get all of that and more now at microcosmos.store. We're going to get right to the point because we are just too excited about today's episode. If you've been following James, our master of microscopes, on some of his other platforms, then you know what's coming. You know that James has published his first academic paper, which was co-authored by Dr. Legendrea and James's mentor, Professor Genoveva F. Esteban. If you want to find it, you can just look for the article titled The Extraordinarily Rare Ciliate, Legendrea loyezae, in the journal Protist. We'll leave a link for it down below. The paper is, as you might be able to tell from the title, about this extraordinarily rare ciliate that you see on the screen now, called Legendrea loyezae. Just how rare is this ciliate? It's so rare that before James stumbled on some of his own, it had only been reported by 4 other people, ever. There are a vast number of microbe species in the world, so many in fact that it seems like a miracle that we are able to find the same species twice. Some of these species are incredibly prolific, reproducing at rates that make them impossible to ignore under the microscope. But then, there are the microbes who turn up once in a blue moon, like mythical creatures of the microcosmos, whose life seems to exist only in a few lines of text and the rare illustrations that preserve them. The first record of Legendrea loyezae's existence came in 1908 from a French scientist named Emmanuel Faure-Fremier. He had been gathering samples from a pond near Paris, studying the mud for what he described as infusoria, a name once used to describe microbes. And among the organisms that he found were just a few of these ovalish creatures with one elongated macronucleus and roughly 20 tentacles of varying length that branched out from their bodies. He named the creature Legendrea loyezae, and he never explained why. Only 6 years later, a Swiss biologist named Eugene Pinard reported finding Legendrea loyezae in his own samples, this time from Geneva. But he didn't just stop with Legendrea loyezae. Pinard found 6 other species that he believed should belong to the genus, including this one, which he named Legendrea bellerifin. There were a few characteristics that made Pinard consider this a new, separate species, but the most important factor were Legendrea bellerifin's tentacles, which Pinard described as being more like, quote, sessile pimples that could extend and retract. In comparison, he said Legendrea loyezae were not capable of the controlled extension that Legendrea bellerifin are. Instead, their tentacles trail behind them as they swim through the water. Alfred Kahl, the prolific documenter of ciliate life, reported his description of Legendrea loyezae in 1930. But after that, they seemed to go unnoticed in the microcosmos until 2014, when a microscopist named Martin Kreutz found them lurking in German ponds. And across all of these descriptions were slight contradictions, differences in how they perceived the cell's morphology that were really difficult to resolve with so few observations. But even in those large gaps of time where scientists weren't finding Legendrea loyezae, they were not forgotten. In 1967, the scientist A.W. Jankowski decided to take an axe to the Legendrea genus, splitting it into 3. The distinction was based on the placement of the organism's tentacles. Legendrea, like Legendrea loyezae, who had tentacles at the end of the cell, would remain Legendrea. Those who had tentacles only halfway in a row around the cell would become loyezae, and those who had extendable tentacles in a row that goes around the cell would be called Thysanomorpha. And that is how Legendrea bellerophon became Thysanomorpha bellerophon. It is not clear why Jankowski made this decision to split Legendrea into 3 genera, nor is it clear why it was accepted in the official taxonomic codes. Jankowski didn't seem to have made any observations of his own to decide these differences, instead using the discrepancies in the rare existing observations to make vast changes in taxonomy without accounting for other possibilities. But that all brings us up to 2021 and the discovery of another possibility. More specifically, it brings us to James, equipped with a plastic bottle, a microscope, and an endless devotion to his craft. Visiting 2 lakes around Warsaw, James carefully gathered samples from the bottom of the lakes and stored them in the dark, with lids shut tight to minimize the amount of oxygen coming in, so that the anaerobic organisms that live in these sediments could thrive. And when he went to see what was hiding within his samples, he found 4 Legendrea loyezae. He immediately recognized it from the pages of his beloved Ciliate reference books and was thrilled to tell his mentor, Professor Esteban. But the most surprising thing would come later. In a microscope slide, James sealed off with petroleum jelly so that he could watch this Legendrea loyezae for longer. He'd been watching it swim around, its tentacles trailing behind, and he kept the slide in a humidity chamber and returned to it over several days, watching as it settled down among some debris. It was clearly alive because there was some movement in the cytoplasm, but it just didn't move, even when James lightly tapped the slide or shined a strong light onto it. But after 4 days, something strange happened. This green euglenid wandered close to the Legendrea, too close, apparently for the Legendrea's comfort, causing it to contract its tentacles. We still don't know what exactly set the Legendrea into action, but the most likely explanation is that the euglena was releasing oxygen into the water, discomforting the anaerobic Legendrea. What caught James and Professor Esteban's notice was that Legendrea loyezae seemed to not only control the length of its tentacles, but also the location. And as they extended and contracted their tentacles, the organism's shape changed. When extended, the tentacles appeared towards the side of the swollen organism. When contracted, the tentacles sprouted from the end of a heart-shaped cell. No one had ever observed this tentacle extension in Legendrea loyezae before, and more importantly, this movement seems to explain the differences between the descriptions of Legendrea loyezae made by earlier scientists. The different shapes they observed were likely Legendrea loyezae in different states of tentacle contraction. And this is really meaningful because it muddles the reasoning behind Jankowski's division of the Legendrea, which was derived in part on a static understanding of the tentacles. And as James argues in the paper, it means that Thysanomorpha bellerophon should become Legendrea bellerophon once more. These observations that James made with his microscope revealed a lot about a rare species, but there are depths that the microscope cannot reach, information hidden in places we need other techniques to reach. We'll talk about that in our next episode. And who knows, with more observation and more data, perhaps there will be more species reverted back to the Legendrea genus, because that's sort of the point of science. There is no end to what we know and what we will learn. There is simply a patient dedication to the work, to visiting the same pond week after week, to watching the same sample day after day, to digging through old books and forgotten texts until they are embedded in memory. We do love quoting a microscopist here on Journey to the Microcosmos, so perhaps we should pay tribute to our own master of microscopes in the ending of his paper. We hope that the study here presented inspires the readership to spend more time looking through a microscope and reminding them that science is done to subside the mind's curiosity, not to incite discord in one's rather short lifespan. Thank you for coming on this journey with us as we explore the unseen world that surrounds us. No matter what we are doing, we are always communicating. It's how we make meaning of our surroundings and interactions. Communications is ingrained in our daily interactions, and even if you feel like you're a great communicator, it's still important to understand that communication is a really complex social process that can change depending on a wide array of factors. And that's why there is Study Hall, Human Communication, the series where they explore communication, unpack why it matters in our lives, and teaches you how to become an even better communicator. They'll walk you through the skills needed to be a good friend, student, employee, leader, and problem solver, and help you better understand how communication can impact your relationships with people. So check out Study Hall, Human Communication at the link in the description. The people on the screen right now, they are our Patreon patrons. They support this channel as we explore this wonderful world of ours that has so many secrets in it that are just waiting to be uncovered. And in this video, we actually got to talk about a secret that was uncovered by our master of microscopes, which is really remarkable. So I want to say thank you very much to all of these people who support so that everybody can enjoy. And if you would like to become one of them, you can go to patreon.com/journeytomicro. If you want to see more from our master of microscopes, you can check out Jam and Germs on Instagram. And if you want to see more from us, there's always a subscribe button somewhere nearby.